Today we are doing chemical reactions in atmosphere. For part 1, we are going to be collecting nitrogen and oxygen gas, so we are going to need to label our flasks that we are collecting them in. So first I will label my N2 flask, or nitrogen gas, and then my oxygen flask, or O2. Now I can move to collect my gas. Now I have moved to begin collecting my nitrogen gas. In order to do so, we need 3 main components. We need our gas cylinder with nitrogen gas, our labeled nitrogen flask, and our trough filled with tap water, which is connected to our cylinder via this hose. Now let's take a closer look at this gas cylinder here. There are 3 valves here on the cylinder. You will have your needle valve farthest to the left, which may or may not be labeled with green tape. This is the valve that you as the student will be using in order to collect your gas. You will open it or close it in order to let gas out from the cylinder. We have this knob, or this valve right here, which regulates our pressure. This is going to be set by the lab staff. Please do not change anything. It will be either taped red to signify you should not touch it, or covered with a plastic beaker so that you should not touch it as well. We have the main valve here. This as well may or may not be covered in red tape, or will be covered with a plastic cap. The main valve will be opened by either lab staff or your TA. Here's some additional useful information for TA. Should you ever find yourself with the gas cylinder not pushing out any gas, even though you have the needle valve open, there are 3 components you should check. 1, make sure that your main gas valve is open. If it is open and you're still not receiving any gas, check to see if you have any gas remaining. This dial here will tell you how much gas pressure is remaining inside the cylinder. If it is starting to get too low, you may not end up having enough pressure in the cylinder to emit any gas. If this, which is reading as it is now, quite full, then next you should check the pressure dial. If the pressure gauge is sitting at 0, then you will need to change the pressure valve in order to have gas come out of the cylinder. The value that we set it at is between 10 and 20 psi, so you will not need to have the gauge reading more than beyond this first or second hash mark here. Now I am ready to collect my nitrogen gas. In order to do this, first I will need to take my flask and fill it with tap water from the sink. I want to make sure the flask is overflowing with water. Let my bubbles escape, and then I'll be taking my rubber stopper, capping it very tightly in order to make sure that no air of any kind has gotten into my flask. I will then invert, place into my trough, and remove the stopper, and now I have my flask ready to go to collect gas. So now you can see my trough is connected to my gas cylinder underneath through this tube. If you could open up the gas, please. As you see, I am starting to have my gas bubble through an opening right down here in the bottom of the trough. We are adjusting the speed to just a very slow to moderate rate of bubbles forming. Next, once the speed is at the correct amount, I move the mouth of the flask over top, and I can now begin collecting my gas. And now I wait until I have collected almost the entire flask full of gas. As you can see, as the gas is filling inside of our flask, the water that was previously inside the flask is being displaced and pushed into our trough. Now that we have gathered plenty of gas, I can go, take my stopper, reach back under, and seal the flask. It is very important to make sure that the neck of the flask stays under the water in the trough the entire time. If at any point the flask is above the water, you will end up contaminating your gas with air from the outside environment. So now I can take my sealed flask up, and I have my flask containing nitrogen gas. Since I know that nitrogen gas is a lighter than air gas, I prefer to keep my flask inverted like this with my water down at the neck near my rubber stopper. This helps create an extra barrier against any air coming through, since my nitrogen will naturally like to sit at the top and my water will sit at the bottom, helping to prevent any nitrogen from escaping or air from entering. Next, we will go and repeat this exact same step with oxygen. So for this, I have my 2 flasks. We are again going to need to label them. This time, however, one flask will be labeled NO1 for our first flask and NO2 for our second flask. The 1 and 2 are not correlated to the chemical formula whatsoever. They are just to signify which flask is which. Here is my setup for my production and collection of nitric oxide gas. I have my copper turnings and nitric acid, 3 molar. I have 2 grams of my copper turnings that I will take and add right to my test tube. I need them as close to the bottom as possible, so I will take my glass stir rod and push them down to the bottom of the tube. Next, I'll be adding 40 milliliters of 3 molar nitric acid. Now I have my nitric acid that I'll be heating right at the top. I do not want to be heating directly on my copper, nor do I want to be heating up towards the top near my burette clamp, otherwise I may end up melting part of the burette clamp. I have my rubber stopper with glass bend connected to my water trough. First NO collection flask and second NO collection flask. This one will likely contain air. This one should, however, be pure. Now I can take and start my Bunsen burner. I have a very gentle flame so that I can begin heating right at the top of my flask. And I will let this go in order to heat the reaction in order to start producing my gas. So I will take my first flask and place it over the opening and begin collecting. Now I will show you how to properly prepare your syringe for when you are doing gas transfer. So first, I have expelled all the air that is in my syringe by pushing the plunger all the way to the bottom. Now I will take my tubing and push it under the water and pull in water into my syringe. As you can see, I have an air bubble right here, so I was obviously not able to get all of the air out of my tube or even out of my syringe in its entirety. So in order to do that, I will invert my syringe. Here I have my setup for combining gases. To start, I'm going to be using nitrogen gas as my gas of interest. I have already secured my 100 ml grad cylinder with water. I'm going to uncap my nitrogen flask. I have purged my syringe, so I will just feed the tube up, and then I'm going to take out 30 milliliters of nitrogen. Now I will add that 30 mils of nitrogen into my graduated cylinder. It is very important to keep all of my components underwater in order to prevent any air from entering the system. There we go, I have added my 30 mils of nitrogen, and my cylinder is reading 30 mils, so I know that I was accurate. Now I will need to purge my syringe again, so I pull up some water, invert and expel. One more time, pull up water, invert and expel. So now my syringe is good for the next gas that I'm going to use. I'm going to be capping my nitrogen since I no longer need it, and then removing from my trough. The gas that I'm going to be adding is my oxygen gas. So I've placed that in my trough, and I am now removing the stopper. I can take my tube and feed into my flask, and I am going to be adding 5 milliliters of oxygen to my nitrogen. Now that my tube is in my graduated cylinder, I can expel my gas. Now I took and added 10 milliliters in order to have a very clear reaction. And as I can see, when I added my 10 mils of oxygen, I now have a total volume of 40 mils, my graduated cylinder. Since the volumes were additive, it means that there is no reaction between the gas. There is also no color change. So next, I am just going to be doing a second trial to make sure that there is no reaction. This time I only took 5 mils. Adding my 5 mils has again left me at 45 milliliters in my graduated cylinder, which means again the volumes were additive and there was no reaction between nitrogen or oxygen. We will wait for approximately 2 minutes to confirm. While I am waiting, I can go ahead and purge my syringe to prepare it for my next combination. About 2 minutes have passed, and I will double check, and I still have no volume change, which means that there has been no reaction between my oxygen and nitrogen. Here I have my setup for collecting gases. I am going to be using oxygen this time as my primary gas of interest. I have purged my syringe already, so I'm going to feed my tube up into my oxygen flask and take 30 milliliters of oxygen, and then I'm going to add my oxygen to my graduated cylinder. Checking my graduated cylinder, I have 30 milliliters of gas in there, so my addition went fine. I'm now going to purge my syringe. Now that I am done adding my oxygen, I can cap my oxygen flask and then remove it. I am going to be adding my nitric oxide to my oxygen. I am using my first flask of nitric oxide that I gathered. We know, since this was our first flask, it is not completely pure, but for this case, the slight impurity to it should not matter. So I'm going to be adding 2 rounds of 5 milliliters of nitric acid or nitric oxide to my flask. So I'm going to pull up about 10 milliliters, but I will add 5 at a time. This is in order to save having to reach into the flask an extra time. I have fed my hose up into my flask or my graduated cylinder. Now I'm going to add 5 mils of nitric oxide. I have 30 milliliters of oxygen in here. As I can see, some brown gas has formed in my cylinder. So since I see presence of a reaction, I'm going to let it go for 2 minutes. Now that some time has passed, I'm going to check my volume, and I see that my volume has actually decreased by a milliliter. So I'm now at 29 milliliters of gas in my graduated cylinder. Now let's repeat the addition with my remaining 5 milliliters of gas. Pay attention to the color in the tube, in the cylinder. And you see, the moment I added the gas, we had a very dark brown gas coalesce in our graduated cylinder. As you also saw, the volume was decreasing as the gas was forming. Now I'm going to check the volume one more time. I have again lost 1 more milliliter, so I am now only at 28 milliliters of gas remaining in my graduated cylinder. It appears that all of the brown gas has faded from my graduated cylinder. Due to the volume change and the color change, we can know that there was some form of reaction between oxygen and nitric oxide gas in our graduated cylinder. Here is my gas setup for my final combination of gases. I'm going to be using nitrogen again as my primary gas of interest. As you can see, I just want to emphasize one last time, I have both of my flask and graduated cylinder clamped to help them stay secure, but they are also elevated in my trough, so the mouth actually has space between the bottom of the trough and the mouth of both the grad cylinder and flask, in order to allow me to easily feed my tube up into the gas. So I have purged my syringe, I'm going to be taking another 30 milliliters of nitrogen. I'll be taking and adding my 30 mils of nitrogen to my graduated cylinder. Checking the volume, I'm at 30 milliliters of nitrogen, as I would expect. So I will now purge my syringe, be ready for my next gas. Now that my syringe is purged, I can cap my nitrogen and remove. And now I will be using my first flask of nitric oxide to test if there is any reaction between nitric oxide and nitrogen. Since this is the first flask that I collected, I know that it is not totally pure, but that is not important for this step here. Our impure version will work just as well as pure to test our reaction. I'm going to be drawing 10 mils of nitric oxide. I'm only going to be adding 5 milliliters at a time for my 2 trials of 5 milliliters, but I am taking 10, that way I do not need to go back into my nitric oxide flask. So now that I have my tube fed into my graduated cylinder, I'm going to add 5 milliliters of nitric oxide. There was no color change in the gas inside the cylinder. Looking at the volume, I am at 35 milliliters of gas, which indicates that there should be no reaction going on. I will let this sit for a moment just to make sure that there is no reaction going on before I add my last 5 mils of nitric oxide. Now that it has sat momentarily, I can see that I still have 35 mils of gas inside my grad cylinder, signifying no reaction. I will add my last 5 milliliters. Again, there was no color change. And looking at the volumes, I am at 40 milliliters of gas in my grad cylinder. So this confirms to me that there is no reaction between nitrogen and my nitric oxide gas. I will purge my syringe while I wait to confirm that there is no reaction. Looking at the volumes, it again has not changed. So I know for sure there is no reaction between my nitrogen gas and my nitric oxide. Here I have my setup, my quantitative analysis of oxygen and nitric oxide. To start, I'm going to take my 30 mils of oxygen. Now I've added my oxygen. Checking the graduated cylinder, I can confirm that I have 30 milliliters of oxygen inside my grad cylinder. So I can now take and cap my oxygen flask and remove. Next, I'm going to be using nitric oxide gas. We are using our second collected flask because it should contain only nitric oxide and be pure, rather than our first flask, which could contain air and be impure. So I'll take and uncap that. Now I will purge my syringe. I have now purged my syringe, so I'm going to feed it up into my flask, and I am going to be adding 10 mils of nitric oxide at a time throughout this analysis. So I'm going to draw up 50 mils initially so that I can do 5 trials of 10 mil addition. Now that I have my 50 mils, I can take and feed my hose up into my grad cylinder, and now I will begin my first 10 milliliter addition. So as you can see, we have a very dark brown gas created. Also, you can observe that there was a volume change since our water level was increasing. I will let it sit for 2 minutes in order to allow the reaction to complete, and then I will read the water level in order to see if there was any form of volume change. I can see that there is no more brown gas in my cylinder after 2 minutes have passed. So I am going to look at the volume change. And I am now at 25 milliliters of gas in my cylinder. So I have lost 5 milliliters of gas in total. I am going to now add 10 milliliters again of my nitric oxide. Again, deep brown gas has formed. I can already see that my water level is rising. So I will let this go for another 2 minutes, and then I will see if my volume change is the same or if it has not changed at all. 2 minutes has passed, and I can see that there is no more brown gas in my grad cylinder. I am now down to 20 milliliters in my graduated cylinder, so I've again lost 5 milliliters of gas. I will now add another 10 milliliters of nitric oxide, and I will repeat the same steps as before, recording my observations. Dark brown gas has formed. We are seeing volume change in the cylinder. 2 minutes has passed. I am now down to 9 milliliters of gas in my graduated cylinder, which means I likely added a little more nitric oxide than intended, since we could see a pattern of losing 5 milliliters every 10 mils of nitric oxide added. I will again add another 10. The reaction has completed. I am now down to 10 milliliters in my graduated cylinder. I will add my remaining 10 mils of nitric acid in my syringe. And then I will go and I will retrieve 40 more milliliters of nitric oxide. The reaction is completed in my graduated cylinder, and I am now down to 5 milliliters of gas left in my grad cylinder. So as you can see, we have a pattern of every 10 milliliters of nitric oxide added, we lose 5 milliliters of gas that we initially had in our graduated cylinder. Now I am going to see what happens with more additions of 10 mil nitric oxide. I have added my 10 milliliters of nitric oxide. The reaction has completed, and I am now at 7 milliliters of gas in my cylinder. I will add another 10. As we see now, no more brown gas is forming in our cylinder, and I am now at 16 milliliters of gas in my cylinder. We are starting to see additive volumes of gas, so I'm adding another 10 milliliters of nitric oxide. Again, no brown gas has formed. I am now at 26 milliliters of gas, which means I have a total addition of gas now. There is no more elimination. I will add my final 10 milliliters of nitric oxide, and I am now at 35 milliliters of gas, which means that after I added approximately 60 milliliters of my nitric oxide, I had eliminated any oxygen that was in my graduated cylinder when I was creating nitrogen dioxide. Now, after I had added another 30 mils at the end, I had increased the volume of gas, showing that there is no more oxygen remaining. Here I have my nitric oxide flask. It is my number 1, my impure version. Here is my suggestion: after you have collected gas, which can be your nitric oxide, nitrogen, and oxygen, you can go ahead and store it upside down. The reason we do this is because the water here creates a very good seal with the rubber stopper. This prevents any form of air getting in and prevents anything escaping as well. To make this easy, instead of setting your flask upside down on your counter like this, you can take your plastic beakers and you can place inside, sitting like that. This gives you a more stable flask. To show as well, it works with your 250 milliliter flask. Here I have my oxygen. Again, as you can see, I have extra water here, and it can sit and stay stable on the countertop for actually likely several days.